We are back once again. This is day 72 of daily LeetCode, right? Yesterday, what were we doing yesterday? Yesterday, I think we were doing coin change. We were implementing some a linked list version, or I guess we needed access to a data structure that had constant time insertion and removal at the front as well as at the end. That's what we kind of went with. So we ended up making like a simple linked list class. We got lost in some pointer sauce, and we should have had the iPad ready to draw some pointers, and we could have made sense. But we failed to do so. We are back once again to the regular schedule. I've been thinking a little bit about the regular schedule. It might change. It might change. So right now we do about 2 hours a day, right? Ignoring the vacation days. There's also the end, right, of the saga of No Days Off, ending with the penultimate installment in the series, right? No Days Off 5, Homecoming. So that's what that video yesterday was. But now I'm wondering if things will change. I want to learn some other stuff as well. And it's only two potential paths here, right? I do 2 hours a day, so it's like an hour of LeetCode, 30 minutes of system design, and then I'll try to read 30 minutes of the ADM. But if I want to learn something more, I either have to redevise or partition the time I currently have to keep 2 hours a total block I spend, or add more time onto the end of it. And it's a bit of a sticky situation, right? Because how much work one does during the day, how much work one does, like how much work I do like during work, or the general bandwidth required for daily existence can chip away at the the learning bar. So whatever the schedule is, it has to be sustainable. So it's a bit tough. So not sure what we'll do. We'll either keep it at 30 minutes. We'll either shrink some things down, like for example, we'll bring LeetCode to 45 minutes. We'll do ADM for 15, system design for 30. That would leave us at exactly an hour and a half, which would create an extra 30-minute block for something else. Right, and that's something else I think is might just be necessary, right, just to explore some of my own interests. So yeah, that's what I was thinking. Besides that point, though, we have legendary comments from Thomas Wong. Coin change is the ultimate question. BFS, 2 types of DFS, and DP. This is actually true, and I think this is also getting to the point as to like why revisiting problems is just so cool, right? Because I think we've been able to extract so much growth out of coin change. It's been kind of crazy. The first version we did was exponential time. Then we figured out a version that was memoized DFS, and then we read the ADM and did a BFS short path version. And then we ended up coming back to it, implement a deck, and do a new version. And that's just cool, right? So I think it's just always a learning ground to pretty much like juxtapose previous solutions with current solutions. And I think noticing that delta is pretty crazy sometimes in terms of growth. So legendary comment by W Human. I'm just that guy. He says, I wait in anticipation for the next title. Legendary comment as always. And so yeah, this video, I'm not exactly sure what we're gonna call it. Actually, I think I have an idea. And then we have QB Cubed dedication, dedicated to you, brother. And so, yeah, I think I actually have an idea for this video. This video's title. I was watching one of the videos back, and I was looking at my hairline, and I think I had some Majin Vegeta type vibes. For those of you who don't know, Majin Vegeta, right? I'm feeling like Vegeta right now. So I'm thinking this video might be a title related to that. So that being the case, we await the title of this video. I'm also learning Ruby right now, and for example, I work on this application, right? That schedules these cards for me to do. The backend is in Node, but I don't really. The backend is just all over the place. I just kind of wrote it to come up with it as fast as I could, and so yeah, I'm thinking it'd be cool to just have like a good backend. Like, I mean, people use Node, right, for backends, but I don't have any professional experience with it. So I think that would be the goal going forward. So Yeah, I want to try and learn Ruby on Rails. But first, it requires learning a little bit of Ruby. And what better other place to do this? So I'm taking a small course on Codecademy, right? Which is useful because you also always want to add some supplemental reading, right? But I'm also looking at this Learn Ruby in X and Y minutes thing. So yeah, we did do some of this Ruby Codecademy thing, which was pretty cool. But I'm also looking at this. This is probably what we use as reference today. But what other place to learn a language quickly? Not maybe in total, and not maybe in its total entirety. Not maybe in its entirety, but why not LeetCode, right? Because there's a lot of different problems that test a lot of different aspects of a language's use. For example, like how you string statements together, maybe how recursion works, maybe how you call a function, maybe how you might be able to need to create a class on the spot and it makes sense, right? And just other things like maybe bitwise operations, string interpolation, objects, functions, loops. And loops can get pretty crazy, right, depending on the program you're writing or the problem you're solving, right? And so, yeah, I thought, maybe we'll just start to do both, right? So some problems I'll do, for now, I want to learn Ruby a little bit fast, so I'm just going to start doing it and start some problems today in Ruby. So it's going to be a bit of a slowdown, but the beauty is, right, we've already solved them in TypeScript or JavaScript. So when we're doing them in Ruby, I think we already know what we're trying to accomplish, right? Kind of like if you were learning a language and you already speak English, right? I guess that's the tough part because sometimes languages don't always, a translation doesn't necessarily always translate one-to-one. But that's also kind of the interesting part with language translation as well and code translation. So we already know the answer in TypeScript or JavaScript. This is kind of based on or is rooted in the way TypeScript or JavaScript works. I guess JavaScript, right, since TypeScript is a superset. But this is kind of rooted in how JavaScript works. So maybe we can do something where we try and use a new language we're learning, and then, yeah, we'll make it make sense. And then hopefully that does the thing. So yeah, that's what we're going to do. And then I'm thinking maybe in the future it'd be cool to just be able to do a random carousel on languages, right? And I think there's also some value to be extracted from knowing how to solve something in JavaScript and then knowing how to solve it in Ruby or maybe another language. So I think this generally helps with the idea of chunking. And I think this is pretty much a concept where, like, they say, like, people have the ability to store 7 pieces of information in their brain at a time, right? And I was reading this book, I think it's called How to Learn, but I think it's written by John Watskin. But basically, if you look at a chess grandmaster versus a regular person, they can't store more than 7 pieces of information as well. But the size of those 7 buckets is expanded because of their pattern recognition or ability to chunk large pieces of information into smaller pieces, right? So these 2 people both have 7 buckets, but one person can compress this really, really large block of information into one line, right? So I think a good example is like, when I first started, I would not be able to really understand what's going on here. I'd feel like I'd have to remember all 30 lines of this algorithm. But now, right, this whole thing can be compressed into one sentence, right? And that sentence is just BFS shortest path, right? And I guess that's kind of what I'm trying to get at with the chunking, right? You don't necessarily have to remember all of this, but it can be hopefully losslessly compressed or compressed with a negligible amount of loss, right? So that would be the goal. But I think there's some value, right? Because languages are different, and there may be some idiosyncrasies in Ruby that allow me to maybe look at this problem from a new light. And so that's what I'm hoping to do. And so, yeah, today will be the first day we do that. So we'll do an hour today, which will probably be taken up probably on one problem, to be honest, because I don't really know how to use Ruby too well. And I think, yeah, it'd be something cool to learn. And hopefully, right, learning Ruby will help us learn future languages. And then, yeah, so that would be the goal. So I'm just going to jump into it. And yeah, anything else that I was going to, yeah. So we're back on the regular schedule. I've been able to sleep. I slept about 8 hours last night. And then I woke up and I felt like an alien. And then I slept for about 6 more hours. So yeah, I actually feel like I'm getting closer to the regular schedule again. And so, yeah, I think we might be able to jump into it. So I think we're going to do, either going to do 45 minutes or an hour today. Either way, I always say 30 minutes. All right, and I ended up going like 58 minutes over because I tend to be quite stubborn. Maybe this is a trait that will hurt or help us, only time will tell. But we'll say we'll start with 45, and we're gonna try and solve our problems in Ruby today, right? So we could end up doing some craziness. It looks like the first problem on the list is binary tree vertical order traversal, right? So we're gonna try that. Also, before we start, don't forget to join the Hyperbolic Coding Coalition /Chamber. This is a legendary chamber of algorithms and programmers who are learning, who are also on their own grind, maybe on LeetCode, maybe on something else, or maybe just working on something else, right? So you're going to want to join. There are thousands of people joining every single day. Thousands divided, yeah, thousands, right? You're going to want to divide 1,000 by, you don't want to divide 1,000 by 1,000, but there are thousands of people joining every day, and yeah, so that would be pretty cool. And yeah, don't forget to join the Hyperbolic Coding Chamber. Lots of cheat codes in there, lots of pretty smart people who are helping me work through these problems, right? So yeah, shout out to all the people in the Discord, shout out to people in the comment, and yeah, let's just jump into it. So we're going to change this from TypeScript to Ruby. This is kind of a beefy problem to just jump into with. I don't even know how to call a function in Ruby yet. So we're just going to say that we're just going to jump into it. So given the root of a binary tree, return the vertical order traversal of its nodes' values from top to bottom, column by column. If two nodes are in the same row and column, the order should be from left to right. So they want a vertical order traversal, right? Let's map this so far to the examples, right? So we're given a tree that looks like this, and it looks like the output we're expecting is 9, 3, 15, 20, and 7. But if we look at this vertically, we can see that they're looking for these vertical groupings, right? So 9, 3 and 15, 20, and then 7. In this example, we have a similar outcome: 4, 9, 3, 0, and 1, 8, and then 7, right? Because these would all be in the same column, and we can see among these orderings, right, there's a left to right, right, 3, 0, 1 ordering. Here we have 4, 9, and 5, 3, 0, 1, 8, and 2, and 7, and then, right, it seems like 9 and 8 both have two different children here, 0 and 1 respectively, but their left and right pointers are both pointing to 5 and 2, I think, is what they're trying to say. It actually is a bit hard to tell. So 3, 9, and 8, and then we have 4 and 0, right? And then we have 1 and 7 for both their children. We have null and null, right, for forced children. Then we have null. Yeah, this one's a confusing picture. 3, 9, and 8. Right, 4, 0, 1, and 7. For 4's children, we have 2 nulls. For 0's children, we have 0 and 2. And for 1's children, we have for 4's children, we have null and null. For 0's children, we have null and 2. And for 1's children, we have 5. Okay. So these are not sharing the same pointers. 0 has 2 as a child and 1 has 5 as a child. Right, we know the number of nodes in the tree is in the range 0 to 100. So we know that, right, we can given a tree with 0 nodes, right? So we know of a traditional way to solve this, right? We can give the root node, right? We can start the root node, right, from a relative ordering. If we could give, if we were to visualize this node, this better way to put it is like this. If we were to visualize this, right, as a matrix, right, and you can just write this box like this, right, and if we just take like a straight line tool, right, there are a few ways that you can actually just break this up and visualize it as a matrix, right? And if we do it that way, then we can see that there's a relative ordering among these among this binary tree, right? And another way to look at it, right, is like this. And so if we look at it like this, we can see that this is kind of what they're looking for, right? But how can we visualize this matrix as, how can we visualize this tree as a matrix? Well, we just have to do some shifting, right? So typically a matrix will start at 0, 0. What if we just say that the matrix starts at the matrix starts with a column at 0. So if we imagine that 3 has a column of 0, right, then whenever we go to a left subtree or a right subtree, we'll simply add or subtract based on the direction of a column. So this column will be where 3 is, will be 0, right? And the column left to it, right, will be -1. And this column over here will be 2. No, this column over here will be 1. This column will be 2. Right, and so how do we know that, right? So if we start at the root node 3, if we go to the left subtree, we'll subtract 1 from our column, which will give us -1. From here, if we go right, we can add 1 to our column, which will give us 1. And if we go right again, we can add 1 to get our column, which is 2. If we go left from this column, we'll get column 0. So it kind of naturally groups them in the order we'd like. The remaining problem, right, is that we're also looking from a relative order of top to bottom. See, they say it, i.e. from top to bottom, column by column. So to get that top to bottom angle, right, we're kind of going to want to avoid a DFS, even though a DFS would technically still get us what we're looking for. I think a BFS is more naturally inclined to give us something like an ordering by vertical height, right? Because we tend to go level and level order traversal, right? So ultimately, we can organize nodes like this, maybe into a map, right, where we have keys, and then from there, we can sort those keys, right? So as we know, we have all these nodes. We can organize all these nodes into a map, right, where we have column -1, which is our key, and it has an array of nodes, right, 9. Column 0, it has an array of nodes 3 to 15. Column 1 has an array of nodes, which is just 20. Column 2 has an array of nodes, which is just 7. So that's the n log n solution, right, organized into map, right, of column to array of values, right? And if we do that, right, we could sort keys, and if we sort the keys, then we could create an output array with the goal values, right? We can also avoid sorting the keys, so this is going to be n log n, right? But what if we have found a way to avoid sorting the keys, right? What we could do is just keep in track, because what are we trying to solve, right, when we keep the keys, right? We just want to keep a relative grouping. What we want, when we sort the keys, we just want a way to order them in the order of their column size, right? Because -1, 0, 1, and 2. So if we're just wanting a way to order them in the order, in ascending order, right? A simpler method to do this in linear time would just be to keep track of the lowest column, right? And largest column. And I forgot we're using Ruby, so you probably want to use snake case. Lowest column and largest column, right? And we can imagine, right, if we had a group of keys for something like this, if we were to take our array that we have here like this, right, our output after organizing it into a map of column to array values is something like this. We have, right, column -1, we'd have 9, right? for column 0, we would have 3, 15, right? For column 2, we would have this array of 20, right? And then for the final column, column 3, right, we would have an array of this value 7. Oops, and I messed up. It should be 1 and 2. Right, when we sort these values, all we just want is for them to be in order. So if that's the case, right, in this case, right, they're already in order, but if we imagine we have a more complicated tree, our hash map might look something like this, right? And so what we really just want to do is get it to how we had it before, right, where everything is sorted. And so if that's the case, really all we want to do, right, since our column is going to be pretty much a sequence of natural numbers, right, all we need to know is our smallest number and our largest number, and we can just iterate over them. So for example, if we knew that our lowest call was -1 and our largest call was equal to 2, couldn't we just iterate over the range of -1, right, going to 2, and then just create a new output array, right? We could just say, hey, get me the array at -1, which is 20, then 0, which is 315. I mean, we start at -1, which is 9, then 0, then 1, and then 2, and we also want to include 2, right? So that's the way we can do it in linear time. So let's go with this solution. Now the problem is actually doing it in Ruby. The first thing we need to do is do our DFS, right? So we need to, like we said, organize, right, it into a map, right? But first, we looked at our constraints and we know that the number of nodes in the tree is 0 to 100, right? So you want to say, right, if, and I wonder if you can do this, not root, right, we'll just return an empty array. Is this valid code? I have no idea. I think it should be, but it looks a little too much like JavaScript maybe. And so let's test it with a test case, right? If we take this one out. What would value unexpected end? Oh yeah. Oh no. Wait, I think, can you do a one-line if statement? Maybe you can. I actually don't think Ruby cares about, I read something in a thing that said Ruby didn't care about white space. I think maybe the problem is that maybe I'm missing end. Okay. Let me see. Is there even a return value in Ruby? Method, oh, implicitly return the value of the last statement. What if you wanted to return early? What if you wanted to return early? I guess we could change it, right? I think what you could do instead, since maybe you can't return this early, maybe we could say, we'll have a value maybe called output, which is equal to an array. We could say output unless not root. Right, unless not root, then it returns null. I guess in the end, our output could just be empty. And so maybe I wanted to return early so you don't end up having to do any of this work. But it's kind of strange that I don't know how to return early. Let me check. I've returned, I think we can do return if not root. Okay, so it's part of the learning process. So that's kind of why I said we could learn it, right? If it'd be easier to learn it in the context of a problem because you have to solve, different methods of like learning how to, pretty much, I guess, functionally translate code, right? Other than that, we want to organize into a map, right? Easier way to write this is to organize tree into a hash of values. So maybe we'll say hash is equal to curly braces, which I think this is how it works in Ruby. We'll have output, and we can remove output unless we'll just say output. And then we want to do a BFS, right? So we need access to a queue. So we'll say queue is equal to the root node to start, and then we could say while and I think, right, we'll just say array I think maybe it's assumed that you can just say dot length. So we'll just say while dot length does not equal 0, right? And I think we do have while, and we actually have to use do. I forgot. Do, and then we'll say end. And then we'll say cur might be equal to let's just say dot pop. We have push. So if we have push, we probably have pop, right? We actually want the first thing, right? So you can actually just do shift, right? And then we'll just say puts cur. And let's return this to our original case. So that's perfect. Probably want to say cur dot val. Right, so that's perfect to start. And so what we can do, right, let's say we want, the way you want to be able to do this, right, we're going to be able to want to do this. So we want to be able to keep track of the current column of a node, right? The root node is going to start with the current column of 0, like we said earlier. And I wonder if you can destructure or something similar in Ruby. Let's say destructure. Oh my god, I think you can. Okay, Ruby might be up next. So we say cur and column. Now what if we did puts cur and call? Okay, so this is pretty dope. Okay, so we have q.shift, right? Now we have the current node, right? And so what we're going to want to do is set this value equal to a value in the hash, right? So if we're doing this BFS, we have 3, right? We're going to want to push this value onto 3. So we're going to say R is equal to an empty array, maybe unless hash dot has or I guess it's hash dot key hash dot key question mark hash dot key column, and maybe we'll just say puts array. Is this valid, Ruby? Okay, Ruby actually kind of fire. Okay, Ruby might actually be kind of fire. Okay, Ruby is kind of flames. This is kind of elegant. This is really cool. Maybe Ruby might be up next, or maybe Ruby is already up. Maybe Ruby is already up, right? And we just didn't know. So say R is equal to 0 unless hash dot key. I don't know. Unless we don't have it. Right, unless we don't have it, then it's equal to this array, right? And then we're going to say R dot push, right? A new tuple on. I mean, yeah, we're going to want to push the current dot value. We're going to want to push cur dot val onto this array. Then we'll say hash, right? Sub call, right? This equal to array. Right, then we want to iterate over neighbors, right? And to do that, I think you're supposed to do iterables, right? Well, we probably don't have to do that just because we're going to have, it's a tree, so we only have left and right nodes. Maybe when you get to more graph style problems, you might have this problem. But to start, we're also going to have to do this thing then, right? If cur end. So is this still valid? Maybe we need do. Wait, so maybe we messed up. R is equal to an array. Oh, no, we were right. R is equal to an array unless we have the hash key for the value. And then maybe we don't need this do. Okay, so we're in business. Now we want to iterate over our neighbors, which is just going to be our left and our right tree, but we don't need to iterate over them. We're going to want to do q dot, well, if cur dot left, then we want to do q dot push cur dot left, and we can duplicate this for q dot right. Oops, I added semicolons by mistake. Maybe you do, oh yeah, maybe you do need ends. Unexpected end, expecting then, or. Maybe you do need a do. No, I'm pretty sure do is for loops. So, yeah, I guess maybe you can't. Maybe this is a strange thing in Ruby, or maybe we're still learning. So I'll move this down. Okay. So we're saying R is equal to 0 unless you have a hash key for the value. Then we're going to push the value, right, for this particular column, and then set hash subcall equal to this array. Now if cur or left exists, then we're going to push this onto the queue. But we neglected to mention, right, that we're using an array of tuples, right, as per line 27. So we're going to want to do call, if we're going left, -1, and then here we'll do call +1 since we're going right. Okay, so I think we're good. And so let's try putting okay. Interesting. Right? So we have 0. Wait a second. Oh, no, yeah. So for, wait, no. It seems like for all groups, the last value we're seeing is the last value in the vertical version, right? So for this array here of 0 with column 0, we should have 3, 15, we have 15. I'm thinking this line right here might be kind of strange. Maybe this has to do with how memory works. In Ruby, we're saying hash subcall is now going to be set equal to this array. Maybe that's something that doesn't work very well. When we start, the array is equal to 0 unless... Actually, I think this is supposed to be a question mark. Yeah, so now this looks correct. No. 0 has 3 and 15. 0 should have 3 and 15, yet it has 20 and 15. One hassle has 20 and 15. This is strange. Pushing, let's see, hash subcall equals array. Now, what if we just print, I'm going to say puts cur, just to see the order in which we're visiting. Oops, should have said puts cur.val. Do 3, 9, 20, 15, and 7. So that is indeed the correct order. Our hash is just all over the place. If we have a value for this key, right? If we have value for this key, wait, actually I'm realizing this doesn't make sense. This is equal to an array unless, right? But if empty array, but if hash.key subcolumn does exist, it doesn't get set to anything. Is there a two-part? Maybe there is no two-part to this. Is there a ternary? No. So maybe we can do something else, right? We'll say hash dot, we'll say hash subcolumn or empty array. So I think this is what we're looking for. For column 0, we have 3, 15. Then for -1, we have 9. And for column 1, we have 20. For column 2, we have 7. Right, now we just need to do the final thing, like we said, keep track of largest and smallest column. So we'll have largest call is going to be equal to negative infinity. I don't even know if infinity is possible. Right. Is infinity possible? Let me Google this real quick. It does seem to be possible. It seems to be using some style of like scope resolution operator. We'll try integer colon infinity. Oh no, it's supposed to be 2 colons, I think. uninitialized constant. Well, it seems like you can use the one I saw. Oh wait, maybe it has to be all caps. The one they use said float, so maybe that's what you have to do. Okay, let me check if there's so I think we might just be able to use infinity. Maybe that's what we'll do. We'll see. We'll just try our right, largest column we want to be equal to negative infinity. Smallest column equal to infinity. This does not work. So maybe the goal we did earlier is float infinity, and we'll do the same here. Okay, let me look this up again. Okay, I think we weren't, it's a name error. So let's look closer. When we make an issue, we'll just say infinity. I think that's the problem because it's a name error, which means we're actually, however we're parsing this is unable to find what the term infinity resolves to, maybe in this float namespace. And so on each time we pull a node off of the queue and it exists, we're gonna say largest call is equal to I'm maybe thinking of a max function. I'm either thinking of a max function or some kind of ternary or something like that. Maybe this is not possible. Maybe it is possible. I'd like to avoid using these large lines if possible. I'm gonna just Google it real quick. After further inspection, Ruby does indeed have ternary, but we also just want to use a max function, so I'll check that as well. Okay, so we could ternary this, but I'm just gonna go with, I think you can do largest call, so I think we can put this in an array and then use an enumerable function. So largest call or cur dot max should return an element, I believe an element or an array, or maybe I think it's going to return an element. So we'll try that and do the same for smallest call, except we'll do dot min, and then we'll put hash. I wonder if you can do multiple arguments to this puts function, or maybe it's, let's just try that. I don't even know if that's possible. So just say puts smallest comparison of tree node with negative infinity, right? And then I have a point here because cur is a tree node. We're going to want to use val here. So our smallest column is not, we want to get the smallest column we're comparing right now with the column and the current value. So what we're getting is the smallest value in the tree. What we actually want is call. Yeah, I'm making some simple mistakes here, but I think it's just because I'm trying to wrap my head around the language. in the code at the same time. This makes sense. And I think all you have to do, right, is have this output array just equal to this, right? And what we want to do is just iterate over the range of smallest column to largest column inclusive. And I think you can do that with for smallest call dot largest call do end. Okay, syntax error, unexpected local variable or method expecting dot. I'm also realizing we want maybe two dots. I don't want to look up too much because looking it up is actually how you don't remember it. Because every time you look up something, then you always have to look it up. But this is one of those things, I think, unexpected do. Maybe that is unnecessary. Right, something like in this dot each do. Okay, dot each do. So for smallest call to largest column dot each do call and I have end. Oh, well, you don't need the for. Yeah, definitely some learnings here. Some learnings to be done here. We're just going to want to push these values right onto the array that exists within the hash. So we'll say hash sub call, right? So interesting. I think the memory usage is absolutely bonkers. The memory usage on this is absolutely crazy, right? Maybe that's a Ruby thing, right? I wonder why that is. Maybe there are some things that Ruby does for you that at the cost of that maybe is incredible memory usage. Right, I know when this runs in JavaScript, it doesn't take nearly as much memory. It takes about 1/4 of the memory in TypeScript. But yeah, that's just very interesting. I wonder why it takes up so much memory. I'm wondering if maybe a lot of these structures, maybe under the hood, do a lot of work. There's a lot of syntactical, I don't know a lot about languages. So I'm not actually certain. That was cool to do though. So it took us, I know we could have probably done this problem in much shorter time in TypeScript, but fortunately, right? Fortunately, there's more to be done. So yeah, we have 4 minutes left. This makes sense. Right, and then yeah, we have a lot of tabs open. And so say that's a pass, and then we'll just do one more clone graph. This is a bloodbath. I don't actually think it's possible for us to solve this. We can barely solve this problem in JavaScript. So I don't even think we can solve this problem, but we can barely solve it in JavaScript. Maybe solving it in Ruby will give us better scope, but yeah. So I think we'll try this one tomorrow in Ruby. But other than that, I think this is a good place to stop for now, just because you can see by my tabs I was doing some Codecademy earlier. So total time today, I would think it's probably already been like 2 hours, maybe even 3. So we'll stop there today. And yeah, we'll catch you guys tomorrow for day 72. Yes.